Hey Math 1B, I'm coming at you with a new video. We're just going to be reviewing how to solve linear systems using substitution or elimination based on whatever we're given. Okay? So, here's what we got. For our first system of equations, it looks like things are set up for elimination right off the bat. We've got our x's lined up, we've got our y's lined up, we've got our constants lined up. By the way, make sure your equal signs are lined up as well. If they're not, then you do not have things lined up. So, we're going to use elimination for this particular system of equations. Now, the question is, do we want to get the x's to be the same, or do we want to get the y's to be the same? My thought is that if one's negative for the y and one's positive for the y up here, and the numbers are technically going to be smaller to work with, 5 and 4 versus 5 and 3, we can just multiply to get the y's to be the same. Now, the number that divides 3 and 15, the smallest one, is 15. So what we can do is say, take this first equation by 5 to make 3y 15y. And multiply the second equation by 3, which will give us negative 15y. And like I said on the last video with elimination, having a plus 15y and a negative 15y is good because when we add the columns, we want them to cancel out. You can only cancel out when it's a plus and a minus if you're adding. So let's get to it. You've got 5 times everything in the first row here, first equation. So 5 times 5x is 25x. 5 times 3y is positive 15y. And then 5 times 12 is equal to 60. All right, do the same thing for the second equation, except you're multiplying by 3 now. 3 times 4x is equal to 12x. 3 times negative 5 is negative 15y. 3 times 17 is 51. All right, like I said, when you have a plus and a minus of the exact same thing, both variables, both constants the same, you can just add all your columns to completely get rid of that specific variable. So we've eliminated the y's. Now we have 37x equals 111. So now to solve this equation, you divide both sides by 37. You can check that with a calculator, but 37 is going to go into 111 exactly 3 times. So x equals 3. All right, so just a brief recap. Step 1 is to get both equations with either the x's to be the same or the y's to be the same. And you want it to be a plus or minus situation. Add the columns as your second step to where you get this equation, and then you're solving it, which is kind of like the third step. But once you get moving with it, it's sort of like the steps almost disappear, and you're just like on the move of, I need to solve this equation. So now, x equals 3. Remember, the solutions to a system of equation is really where does this line intersect this line. So it's going to be an ordered pair. So right now we know 3 comma something is going to be our answer. We figure out what the something is, the missing y value, by plugging x equals 3 into either the first equation or the second equation. So I'm just going to go with the first equation because there's no negatives, and usually we tend to drop negatives if we do make mistakes like that. So taking this first equation, 5x plus 3y equals 12, I'm going to plug x equals 3 in for the x, so the x disappears, and it's being replaced with the 3. So now 15 plus 3y equals 12, minus 15 from both sides. 3y equals negative 3, and then you divide both sides by 3. Y equals negative 1. So the answer is 3, negative 1. That's the ordered pair on the xy plane where these two lines are going to intersect. We found it without having to graph anything. Let's check out our second example. I'll just rewrite it so we can see it a bit better. X equals 3y minus 2. X equals 4y plus 2. Now here's the thing. All the variables you want are lined up nice and neat. X with X, equal sign, Y with Y, constant with constant. And that usually indicates that we should go straight for elimination. And you can on this particular problem. However, whenever you've got the same variable isolated by itself in both equations, usually substitution is going to be your best route. So how does substitution work? Substitution says get either X or Y by itself. Done. We don't have to do that. Then you replace the X in this equation with the quantity that X equals in the other equation. So I'm really just setting, since both X's are by itself, 3y minus 2 equals 4y plus 5. All right? So if you've got this, it usually just means set the two right-hand sides equal to each other and solve. And it's a pretty basic equation to solve. You want to get the y's on the same side together. I am going to subtract this 3y. Okay, so no more y's on the left. And then I want to move the constant on the right to the left. All right, so negative 2 minus 5 is negative 7. 4y minus 3y is 1y. Now, I can divide both sides by 1, but dividing by 1 doesn't do anything. You've technically solved it. Y equals negative 7. All right, so again, these represent ordered pairs. So the solution is something, some x value, comma, negative 7. So how do we find that something? How do we find that missing x value? You just pick one of the originals. Let's just say I picked the bottom one. And it's exactly like the elimination method in terms of this step. We're just taking one of them and saying, hey, y equals negative 7, so that y is going to disappear and be replaced with negative 7. X equals negative 28 plus 5. Opposites subtract, so keep the sign of the bigger one, but subtract the 2, it's going to be negative 23. All right, let's do 2 more examples. All right, so you got y equals negative 4x plus 1 and y plus 4x equals 3. Now this is a situation where I was talking about earlier. If your equal signs are not lined up, then you cannot use the elimination method. So I've seen students here where they say, hey, I got minus 4x and plus 4x. All we got to do is add the columns right away. So they'll add these, and they'll come up with what seems like a legitimate answer. However, if it's y plus 4x here, and it's y equals negative 4x there, they are not lined up. Okay? So, in fact, in this situation, I think what I'm going to do is just use substitution because y is already by itself. All right, so what substitution says is if y is by itself in one of the equations, what you can do is take that what y equals, all right, and then that's going to totally replace the y in the second equation. So negative 4x plus 1 is going to replace this y value. And then you still have the plus 4x equals 3. Now, if you remember things from our polynomial review chapter, or the section that we did a few weeks ago, if there are parentheses and nothing's in front of it, then you can just multiply everything by sort of like that phantom 1. So 1 times anything doesn't change what's in the parentheses. So you get negative 4x plus 1 plus 4x equals 3. So normally if you've only got a positive constant or a constant on the left, you're going to move it to the right because there's nothing for this constant to combine with if there's just two x values. And then you get negative 4x plus 4x. Well, negative 4 plus 4 is 0. And you get 0x, which can be tricky. 0 times anything is 0, so technically this, you can't suddenly divide by 0 and say you've got an answer, because 2 divided by 0, if you do that in your calculator, like try it, and it'll usually say like, maybe it'll say like domain error or divide by 0 error. It's because you can't divide anything by 0, all right? 0 times what gives you 2? Nothing. All right, so the reverse, like when you reverse engineer to figure out things through division, like it just isn't working here. So you're kind of left with 0 equals 2. That whole dividing by 0 was sort of a nonsense step. And this is certainly not a true statement, right? Nothing does not equal 2 of something. So when you see the situation, let me give you some context. It's going to be no solution. And if you remember the symbol for no solution, it was sort of a circle with a slash through it. But getting back to this whole idea of, we're talking about two lines, all right? Where do those two lines intersect? Well, this is saying they don't intersect anywhere. They're saying that there's no solution point where the two are going to meet, which when you think about it, if I subtract the 4x from both sides, I get negative 4x plus 3. They're two linear equations where the mx plus b, the m's are the same. When the slopes are the same, we talked about that as being they're parallel lines. Parallel lines do not intersect anywhere. Therefore, there's no point where they would have a solution. All right, I'm going to have to hustle and get through number 4. So my first equation, I got negative 2x plus 3y equals negative 6. And then I got 12 equals 4x minus 6y. The symmetric property says that I can rewrite this one so that the 4x minus 6y is on the left and the 12 is on the right. That's just like somebody saying, hey, 5 equals 3 plus 2. And 3 plus 2 equals 5. Both of these are true statements. So the symmetric property holds that I can just rewrite it as 4x minus 6y equals 12. Okay? Now think about it like this. I've got the x's lined up, the y's lined up, the equal signs lined up, and the constants lined up. This has elimination method written all over it. So if we want to say, let's get the x's to be the same. I want a 4 in front of the x's. I got a 4 here. I got a negative 2 here. Multiply the top only by 2. All right. If I multiply the top by 2, you know what? I'm going to rewrite this underneath. I get negative 4x, 2 times negative 2x. 2 times 3y is positive 6y. And then 2 times negative 12, or negative 6 is negative 12. From there, we add the columns. 0, 0, 0. Okay. All the cancels, all the variables canceled out, so we're left with 0 equals 0. This is actually a true statement. It's not like the 0 equals 2 on the previous one. This checks out. And I will refrain from doing this, but if I get y by itself in both of these equations, they will be identical linear equations, which means they're the same line. So when the same line is graphed on top of the other line, then there's an infinite number of points where they intersect. We talked about it as all points on the line is the solution, so all points on the line. All right, hopefully you guys found this helpful. Good luck with the assignment.